Hi guys, today we're going to learn more on error. Let's recall the alternating series reminder theorem. If a series has terms that are alternating, decreasing in magnitude, and having a limit of 0 as n approaches to infinity, then we say that the series converges so that it has a sum s. If this sum s is approximated by the nth partial sum, s sub n, then the error in the approximation, which we can call r sub n, absolute value, which equals to s minus s sub n, or actual minus the approximation, will be less than the absolute value of the first omitted or truncated term, that is going to be the absolute value of a sub n plus 1. In other words, if the three conditions are met, what we can do is approximate the sum of the series by using the nth partial sum, s sub n. And your error then will be bounded by the absolute value of the first truncated term, a sub n. Okay? So what are we going to do here? Well, let's see this example. In this example, they tell you that the Taylor series about x equals 2, so you know that that's your center. Okay, for a certain function, f converges to f of x for all the x's inside the interval of convergence. Then the nth derivative of f at x equals 2 is given by f nth derivative evaluated at 2 is equal to negative 1 power n divided by 3 power n, and f of 2 is equal to 1/3. So they give you the original, and this is the generalization of all the derivatives. Now they are asking you to write a second degree Taylor polynomial, so the maximum power of this polynomial should be 2, for f about x equals 2. So since you know the Taylor polynomial form, what we're going to do here, they want you to write a second degree Taylor polynomial, which is going to be here. So I'm going to leave some space for more work if needed. So what are we going to do? We start with f of 2 in this situation, which is 1/3. Then what are you going to do? You want to find your first derivative. To find the first derivative, we need to use this one. And what you're going to do is you're going to replace the n for 1 because it's the first derivative. So you have that the first derivative is negative 1 power instead of n. We have that it's going to be 1, then divided by 3 to the power of 1. So this is going to be negative 1/3. So you know that your next term is negative 1/3, and then you know that the Taylor polynomial form is going to be x minus 2, divided by 1 factorial. After that, you're like, okay, this is degree 1, so I need to keep going, right? So the second derivative evaluated at 2, what are we going to do now? You're going to replace this with 2, this with 2, and this with 2. So you have negative 1 power 2 divided by 3 to the power of 2. So this gives you 1/9. So what you can see here is that you have plus 1/9, and then you have x minus 2 to the power of 2 divided by 2 factorial, because that's the formula. So after that, you're like, hey, is that it? Pretty much yes. So you're done with this. I mean, you can simplify it a little bit. You don't need to, but you can, right? So we have a situation like this. I don't need the 1 factorial because that's a 1. And then I can multiply the 2 times 9, and you have 1/18, x minus 2 to the power of 2. And that's pretty much it for the second degree Taylor polynomial for f about x equals 2. Isn't that nice? So please remember that knowing your Taylor polynomial form is very important and makes this situation way easier. So now, for part B, they are telling you to use the information above, and then you need to show that the second degree Taylor polynomial for f about x equals 2 approximates f of 3 with an error less than 0.01. So we know that this is equal to 1/100. So what are they asking you to do here? First of all, you need to find the truncated term. So what you have here is an approximation of f of 3. So what you have is f of 3, and I'm going to approximate it with that. So you have that this is your denominator, so then you have this equation. And remember, you have a 3 minus 2. Then you have plus 1/18, and then 3 minus 2. What would be the next one here? This is not enough, because you know that this, the equation here needs to be what the denominator needs to be greater than 100. So you compare it, and you're like, I need to keep going. So what will be the next term? The next term, based on the formula that we have here, it would be 3, 3, 3. That honestly we don't care about the sign, because you know that we have an absolute value. So the next one that we have, it would be negative, right? It would be negative, and then you would have 1/3 to the power of 3, and then you have that it's 3 factorial divided by 3 minus 2. Now ask yourself, this 3, so we keep going, right? This is a 9, this is a 6, okay? This is a 9 times 3, so that's a 27, okay? So that's a 27 times 6, okay? So this is way above 100. Do you see it? Okay? So you don't even need to write it, okay? I'm not going to write it. I'm going to leave it like that. So pretty much what you have is that this, okay, this guy that we have over here is what we call the truncated, okay, term. And why is that? Because this gives you 27 times 6, which is greater than 100, okay? So you see that that's my truncated term, okay? So what's the next thing that we have over here? Okay, we need to prove it, okay? So you have that error, okay? The error, okay, is going to be what? It's going to be less, okay, or equal, but in this case is less, okay, than the absolute value of the truncated term. What's this famous truncated term that you have? It's negative 1 over, and you have that it's 27 times 6, okay? Do you agree with that? And you know that, what's the business here? You know that 27 times 6 is going to be 1 over 162, okay? Which you know that this is less than 1 over 100, and we are very happy because we prove that the second degree does, okay, the Taylor polynomial, the Taylor, okay, polynomial, okay, degree, what was it? Degree 2, okay, approximates, and you don't need to write it, f of 3 with an error, okay, less than 1 over 100, and we're very happy about that situation. Isn't that nice? Now, the other error that is super important is the Lagrange error bound, okay? So when you are going to apply the Lagrange error bound, when your series is not alternating in this situation, okay? So let's read this problem. Let f be the function that has derivatives of all orders. Assume that f of 2 is 4, f prime of 2 is negative 1 over 3, double prime of 2 is equal to negative 1 over 5, and triple prime of 2 is equal to 3 over 7, and then the graph of the fourth derivative on the interval 2, 3 is shown to the right, okay? So we have that it's inclusive, so let me just write that, okay? Then the graph is increasing, we can see it there. You have that this is x and this is your y, in case that you don't see it there on the other side of the screen. And they are asking you to find the third degree, okay, so third degree Taylor polynomial p of x about x equals 2, so you know that your center is going to be x equals 2 for the function f. So what are you going to do? Very similar to the previous problem, you have that p of 3 is going to be equal, and you start with your original, which is 4, minus 1 over 3, x minus 2, y minus 2, because that's your center. After that, you have that it's going to be minus 1 over 5, x minus 2 to the power of 2 divided by 2 factorial. And then we keep going because this is degree 3, so you have plus 3 over 7, x minus 2 to the power of 3 divided by 3 factorial. And we stop here. Why? Because you know that this one has power 3, so we stop over there, okay? So let's leave it like that because this one is very big, okay? Well, not very big, but okay, so we can leave it like that, okay? So they tell you, use your answer to part A to estimate the value of f of 2.8. So what are we going to do here? What you're going to do is you're going to estimate, okay? So you have f of 2.8 is going to be roughly, okay, P3, okay? So this and this is going to be equal to what? 4 minus 1 over 3, and then what are you going to do? 2.8, okay, minus 2, okay, minus 1 over 5, 2.8 minus 2 to the power of 2 divided by 2 factorial, and then plus 3 over 7, okay, 2.8 minus 2 to the power of 3 divided by 3 factorial, okay? So that's going to give you some number, okay? So when I plug that in my calculator, that if it was the AP test I would leave it like this. When I plug it in the calculator for it's going to be 3.706, but you can leave it like this, right? Don't even simplify it, right, if it's in the non-calculator portion, okay? So but so you understand where it comes from, okay? So that's going to be your estimation, okay? Now great, right? Now the next question is use the information from the graph of the fourth derivative to show that the error, this guy that you see here, okay, this is the error, is the absolute value of the error, okay, is less than 1/8. Okay, so what are we going to do here? Okay, what is, okay, the highest point, okay, that you see here in the fourth derivative? Okay, so just look at it as if you were in algebra 1 or 2. The highest point here that you have is 7. The highest point is 7, okay? But it's the fourth derivative. So you're like, how can I connect this? Okay, so you know by the Taylor's theorem, okay, that the remainder, okay, in this case we have 3, okay, why 3? Okay, because we know that we have everything with 3's and they are giving you the fourth derivative. In addition, we have the value of x. What's the value of x that they are giving it to you? This is x. So instead of x, I'm going to put 2.8. Okay, that's going to be the error. This is going to be equal to the error. If you prefer to just write error, go for it. Okay, so what you know is that this is equal to what? The fourth derivative evaluated at this value z that we don't know. Okay, times 2.8 minus 2 to the power of 4. Why 4? Because the fourth derivative. Okay, all of this divided by 4 factorial, and this inside the absolute value. Okay, because you don't know if it's positive or negative. Do you agree with that? Now, you are going to be like, now what? What am I going to do here? Well, remember something. You have the value, the maximum value of the fourth derivative from the interval 2 to 3. What's that value that we were talking about when we were seeing the graph here? That value is 7. So you know, okay, so what we know, okay, we know, okay, over here, that the fourth derivative, okay, for any x, okay, for x's inside the interval, what was it, 2, 3, okay, we know that this is bounded, or the maximum can be 7, okay, from the graph, okay, from, the graph. Do you agree with that? So what we have here is that this, okay, this guy that you have, the maximum that could be is 7. So you have that, oh, okay, so I'm going to replace that for 7 and then the rest leave it the same. Yes, you know that this, what's going to be that's 0.8 to the power of 4 of this divided by 4 factorial. You're going to tell me why you just remove the absolute value just magically, because I know that it's positive. Okay, so now what do you know here? What we have, okay, continuing with that thought here, you know that 7 times 0.8 to the power of 4 divided by 4 factorial, okay, is going to be less than 1/8, okay, as we want it to, so we're very happy, and that's it. If you don't believe me, I plugged this one in the calculator, so don't worry, okay, so, and you have that this is 0.119, and you know that that is less than 1/8, okay, so that's how we prove the situation. So in this situation, we're using the fourth derivative because your approximation was based on the third degree Taylor polynomial. Remember, we always go one above, the one that you have for Lagrange error band. Okay, so I hope that you find this video helpful. If you have questions, just let me know, and I'll see you next time. Bye.